Good afternoon and welcome to today's Rutico webinar, where we'll be looking at the new PointMax IO system from Rockwell Automation. My name's Steve Earle. I'm a product sales specialist for automation and software, looking after the Midlands region.
And I'm Darren Welsh. I'm also an automation software specialist working in the Northwest region.
Okay, so as we said, today's webinar is an introduction, an overview to the new PointMax remote IO system from Rockwell Automation.
So the agenda's in 4 sections today. We're going to have a little bit of an introduction to the platform. Then we're going to dive a little bit deeper and see some of the technical capabilities of it with a technical overview. And then we're going to see some of the design of it and its capabilities from that design. And last of all, should you require any further information, we're going to talk about what resources are available for you to have a look at. And this presentation will be available after this meeting.
Okay, so let's start off with a high-level view of the platform itself, just to introduce what PointMax IO actually is. So PointMax IO, Bulletin 5034, we can think of that as the sort of next generation of PointIO, which obviously has been around for quite some time now. From a general perspective, we can look at the main benefits of this new iteration of this platform being compact size, so smaller footprint when you're fitting this system into your panel. Also, we've increased the speed of communications generally around the island and outside of the island itself. So the backplane speed is up to 1 gigabit per second, and the Ethernet IP speed is up to 1 gigabit per second as well, out to the field devices and PLCs that are controlling this island itself. All of the things we talk about today should be available and released right now, so we can make use of those. And it's good to see that from launch, we've got over 90% coverage of all of the IO modules that are currently available in PointIO as well. So we can just leap straight into this new PointMax IO system with the knowledge that we've got pretty much everything there that we're going to need for our applications.
So let's have a little look at what's involved in PointMax IO. So as you can see in this slide, it has a header, which is Ethernet, gigabit capability. You can have it in 2 formats, but it is strictly copper at this point in time. You can have up to 16 modules, then a power supply and a further 16 modules. You can have 32 modules, any mix, whether it's safety, standard, mix and match to suit. There's no extra requirements to put extra power supplies here, there and everywhere like PointIO was. And for the first time in this lower end of IO platform, we go up to 16 point digital input and output modules, as well as all the usual modules that we do: analog, heart, safety, relay, etc. And Steve's going to talk about some of these a little bit later. So pass it back to you, Steve.
Okay, so just a brief slide here just to say that all of these modules, communications adapters and the like that we talk about today, they're all available in 2 versions. So there is a standard version and an XT version for extreme environments. Both versions of these modules have the same operating temperatures, same shock and vibration resistance. The main advantage of using an XT version is the conformally coated components, which then obviously allow you to introduce those islands into more corrosive atmospheres and use in more extreme conditions in that respect. So that is all available one way or the other, depending on the application that you need.
So let's have a look at the system compatibility with PointMax. Obviously, it's a brand new system, and Rockwell have stated that you need to use their more modern PLCs in order to have this on the network with them. So in the case of the ControlLogix and the GuardLogix PLC, it has to be either the 5580 or 5590, which has recently been released, or if it's a CompactLogix or a compact GuardLogix, it needs to be a 5380. Or for the third option, you can use the 5480, which essentially is a CompactLogix with a Windows OS built in at the side. As a final caveat, we also need to use Logix Designer version 36 or later with PointMax.
Okay, let's take a little bit of an overview at the different modules and components themselves. We'll dive into some of these a little bit more later on. All of these modules we look at are all available in both the standard and the XT versions. But from a communication perspective, there's just one single option, which is the 5034 AENTR, which is a copper-based Ethernet IP adapter with two copper-based RJ45 connections on the front. Most of the modules are similar as you'd expect from a platform like this, but some of the highlights really are from a digital module perspective. We've increased the density of those modules, so as well as having the 8-way modules that PointIO had before, we've now got 16-way modules as well. And also a universal digital module. So these are 8-way modules, probably more beneficial for smaller I/O counts, as they provide the ability to define channel by channel whether each channel is an input or an output. So it's a mixed module, if you like, but you can split how many of each of inputs and outputs are available on each of those modules that you use. As well as the digital safety input and output modules, and a fairly similar list of analog modules there as well, covering everything from voltage, current, temperature, heart support and the like. There are some Rockwell speciality modules now as well. So from Rockwell, there is now a 4-channel IO link master module, a high-speed counter module, which will support both incremental and absolute encoders, supporting an SSI interface. And there's a serial module as well, which we'll talk about briefly later on in the presentation. Looking then towards some of those ancillary items, again, we'll talk about this a little bit more later on, but essentially those top 2 removable terminal blocks there, the 18 and the 18S, are supported on all of the Rockwell modules that we've talked about and will mention today. And the only option between the two is one's a screw terminal and one's a spring push-in terminal. So that's your preference as to which one of those you want to choose. From a base perspective, essentially, again, you're just looking at a single base, which is the 5034 MB. The SA version, Darren will talk about a little bit later on under certain circumstances. And then there's, as before, there's an expansion power module to inject further power supplies into extended bases with lots of modules attached. There's a potential termination module that can sit alongside a module, and that's there purely as a wiring solution to put in place all of your plus volts and commons and things like that. Again, perhaps to save panel space by not using external terminal rails to actually make those connections from the field. As well as all of the Rockwell products that we'll talk about today, as per usual, the technology partners have come and given their input into what might be good modules to fit into these systems, with the likes of Hardy Process Solutions, who have supplied a Wayscale module associated with all of their other offers with load cells and the like, as well as Spectrum Controls with the usual input source and output sync, the opposite way round to all of the Rockwell digital I/O systems that we tend to see usually. Moving on then, Darren.
So let's have a little look at the platform technical overview now, should we, Steve?
I think so. Off you go.
So let's dive a little into the construction of the PointMax system. It's a 3-piece design, which means there's a base, there's the actual module, and there's a terminal block that goes with it. And you require all 3 for each slice in order for it to work. It's an active base with automatic slot addressing. It's got 1 gigabits per second backplane speed, so it's quite an increase on PointIO. And it has on the system side and backplane management as well. It's got keying, so you can make sure that you put the right module in the right place, and it supports removal and insertion under power. You can have any mix and match, as I've already said on there, and you can do online and offline configuration as well if you want to. The removable terminal locks, as Steve said, there's 2 types. There's either the spring-based one or the screw one, and there's some custom labeling available at the top should you wish to use it, and you can add shield termination / retainers at the bottom. If you've got specialty cables, you need to either have floating grounds or alternative cable retainers in there.
Excellent, thanks Darren. So when it comes to installing these islands into your panel, are there any things to consider there? And essentially you can install this in any which way you like. So the traditional horizontal mounting against the back wall, you could also mount it vertically, upside down, hanging from the ceiling. There's no restrictions on the way you position these modules when you mount them in the field. The only caveat to that really is that if you're not putting it in the traditional horizontal mounting position, then you'll need to apply a derating of the ambient temperature range down from the +60 maximum down to +55, which for most cases I would think is still plenty high enough. So Darren, let's talk a little bit about footprints.
Yes, so we've done an example footprint here on PointIO as an example, and we're going to compare it to PointMax. So in this case, and the case we're going to do in integrated architecture later, we're going to use 16 digital in, 16 digital out, 4 relay, 8 safety in, 8 safety out, and 4 thermocouple modules. So as you can see in this, to start off with, if you were to utilize PointIO, you would have a 232 mil wide unit because you've got the modules, you've got the Ethernet header, and you've got an expansion power supply that's required due to the amount of IO in there. If we move forward now and we go to 8-way digital inputs and outputs, so we keep it exactly the same as much as possible for the PointIO, what you'll notice straight away is we've saved just over 22% of the width already. And how will we achieve that? Well, if we think about it, we've lost the expansion power supply. The safety modules are the same width as the standard modules, so that's saved equivalent of 2 modules in the old PointIO, and the thermocouple module is now in a 4-way module rather than two-way modules. If we go a little bit further and go, we're willing to use 16-way input and output modules, what you'll see, it further saves space. We go down to 35% save in this case, and that's purely by the fact we've lost 2 further modules in the PointMax range, having gone from 8 to 16-way digital in and digital output modules. It's quite a saving, isn't it, Steve?
It really is, yes. Okay, so great space savings there inside the panel itself. Let's take a little closer look at some of the features of the individual elements of this system. And let's start with the communications adapter itself. So here we can see 2 versions of the communication adapter, the standard and the XT. And this is here just really to highlight the differences visually between those standard and XT versions of PointMax IO. The standard one and all standard modules will have some lighter grey colour elements to the modules, whereas the XT versions are all that darker smoky colour, so you can easily identify in the field what types of module you're actually looking at and dealing with. Not that there's any difference in functionality, but if you are in an extreme environment that needs that corrosive conformal coating, then it's nice to know that everything there is as it should be. So looking around the module itself, there's a removable flip-up cover at the top there, and underneath that we see the usual 3 rotary switches, which are just one of the ways that we can assign IP addresses into the PointMax IO. Some standard LEDs, as you'd expect, giving you just some basic feedback on module network, is it powered up, and the like. And 2 RJ45 copper connections going out to Ethernet IP, Ethernet network, and they support a number of network topologies, which we'll come back and just briefly mention in a few minutes' time. The removable terminal block for the comms adapter has now split that module power and that sensor actuator power into 2 separate supplies into the comms adapter. And what this perhaps means is that you could choose to supply your module power and your sensor actuator power from 2 separate power supplies. So if you lose power to sensors and actuators, you've still got a working PointMax IO rack, which can give some diagnostics to the fact that things are not communicating properly anymore back to upstream SCADA systems, software tools and the like. Lastly, on this slide, you can see in the center there on the right of each module, there's that symbol for NFC. So one of the first products from Rockwell to support NFC features. And Darren will talk a little bit more on the next slide about some of the IP connectivity and the NFC functionality. Over to you, Darren.
Thank you, Steve. So let's talk a little bit about the connectivity IP setting, whether we're using standard features, perhaps we already know, or these newer features. So there's several methods we can set the IP. As Steve's already said, there's that rotary switch where we can set the last octet. We can use factory talk links, Oris Links Classic or Boot P, or indeed web server on modern products. For the first time, as Steve said, there's this NFC feature, this near field communications that's embedded in the unit. And this is available without power while it's in the box. So literally you can buy the box from us, have it delivered, and if you've got Device Tools app, which is an app available either on the Apple website or Google website, and there's a link later to get to that if you want to, that's available. So what I will say is we've shortened the sequence on this as there's many things it can do over and above setting an IP address. It can see multiple things in there. So let's have a look what it can do. Let's drive it. We're going to log in and scan the device. You get it close, it sees it. It brings back what data it's got. It knows what it is. It knows if it's got any format already. You can do other things in there. And we're going to go and set the IP configuration in this. So we can either go and set it as multiple if we're doing loads of them, or individually. In this case, we're going to choose a static IP address. We're going to drill down and we're going to put an IP address in there, a network mask, and any other things that we need to do in there. Once we're happy with it, we can choose whether we want incremental for multiple devices, and we can click continue. And then we're going to scan the device to download the configuration to it. And notice it's double checking, do you want to apply these changes? We're going to go and apply the changes. It's going to rescan the device, applying the changes, and bring back the information just to show that you've set this device. So it's nice and simple, easy and out the box, and you can do multiple devices in there and register them as well for other things as well on the site. So Steve, let's move on, shall we?
Okay, so let's jump back now just briefly into that network connectivity for the communication module, the AENTR. So those two connectors on the front, they can be attached in a star network or a linear daisy chain type network, as you'd expect. They also give a level of high availability with device level ring, but now as an improvement from PointIO itself, they also support parallel redundancy protocol, or PRP, which gives multiple failure points in a high availability network system using two separate LANs, or we're talking to the same devices through specialized switches. So for more critical infrastructure where you need more availability in your final solution, that could be a good device to use in those situations. And so that obviously fits very well into applications where you're using control logics redundancy. So if you've got two controllers, a primary and a standby in separate racks, then PointMax IO is a good solution, ideal remote IO platform for both DLR rings and PRP meshes to support those high availability networks out in the field. Over to you for bases, I think, Darren.
Oh, thank you very much, Steve. Shall we have a look at the base, guys? So
I'll do that bit, shall I?
Do you want to?
Yeah.
Fair enough.
Let's look at the field power distribution across the backplane itself. Okay, so as we said earlier, the module and the sensor actuator power are split into two separate feeds in that communications module on the left-hand side there. Looking at the module power first of all, that module power will supply up to 16 modules in the PointMax IO island. Any 16 modules in any combination, in any order, it doesn't matter. 16 modules is what that will supply. After those 16 modules, you'll need an expansion module, which to inject a further module and SA power into the system. And that then supports a further 16 modules to the right hand side of that, giving you a total of 32 modules in any PointMax IO rack. If we move across to the sensor and actuator power, which is there to supply all of the field devices that you're connecting into your modules themselves, that gives you a maximum of 10 amps supply from that initial power in the communications module. Now that may be okay for all 16 modules, and you'll get another 10 amps when you put your expansion power supply in. But if you use more than that before you get to your expansion power supply, then there's this separate module base, which Darren will just talk about briefly in a moment, where you can inject a further 10 amps and renew that supply for the sensors and actuators you've got connected into your system. Lastly, if you're using AC devices out in the field, then the power for that is supplied externally and wired directly into the front of the modules, rather than taking anything from that SA power supply, which will only be the 24 volts DC supplied at the left hand side there. So a little bit more on the module bases then.
Thanks, Steve. So as Steve's alluded to, and we've talked about already, there's only two bases that you can choose. There's the standard base, and if your system suits with the standard base, you can just use those. However, if you need to inject extra power, you need the 5034 MBSA. Both of the units pass to the right hand side, but the MB passes straight from the left to the right, so it just passes on whatever power's there, whereas the SA powers into the module and to the right of the module. Those of you that are aware of the older PointIO system, it's kind of like an FPD, a field power device. So it allows you to create a different power zone if you want to as well. And there's a picture in this slide just as an indication of what it looks like. As we've already said, it's 1 gigabit per second across the backplane, and any module base can act as an address reservation module, much like you used to have in the PointIO.
Okay, thanks, Darren. Let's take a look at the modules themselves now, the IO modules that we put in our system itself. As we've said, from a digital module perspective, the main change here is that the density of those modules is now a 16-point module available. There's a 2 amp high current output module with 4 points on it, 4 channels. And all of these modules have got some basic counter functionality as well now, built into those standard IO modules. From the pictures you see there, you can see that there are some color coding alongside the terminal strips on the front. So that gives you a bit better indication while you're wiring up as to what different terminals are for what use. So the blue on the left there for digital inputs, the green for digital outputs, the black color at the bottom for the commons, and you'll see some other colors as we go through some of these modules that we're looking at right now. So lots of ease of use features in this new PointMax IO system. These universal digital modules, 8 points, 8 channels, and as we said earlier, these can be individually allocated for inputs or outputs granularly within that single IO module. So for small point count systems, that might be really useful, again, in cost and saving panel space once it's installed. And again, these support 50 kilohertz counters built into these systems, as well as some pulse width modulation or pulse train output features if it's configured as an output itself. Digital IO modules, not too much to say about these that you wouldn't expect. Everything really there, current, voltage, 8 channel maximum, RTD and thermocouple inputs are available, all with 16-bit accuracy. And we'll talk about the CJC options for the temperature inputs in a little while. Analog outputs, 4 channels, 16-bit again, pretty much as you'd expect to see.
So let's have a little look at the speciality module. In this case, it's an IO Link module, much the same as we have in PointIO, except this time we support 4 IO Link channels and 4 fast digital configurable channels. It's IO Link versions 1 or 1.13, and you can device configuration, it can be online or offline. And best of all, if you keep totally with Rockwell, it's got Premier integration with Rockwell automation, third-party devices in there. So if you look on the right hand side, that's a little look at what Logic's designer would look for this iLink module on version 36 or later. You can see in the project tree, if you squint, I guess. Can you squint in, Steve?
A little bit,
yeah,
a little bit.
Yeah, you can probably see the IO-Link module in there, and we've done a couple of pop-ups from there just to show what depth you can go down with the various modules in there, and the depth of the data and the configuration of it as well. So you can see it's quite an in-depth and usable product. Rockwell thought long and hard and made it as easy to use as possible. So let's look at the heart modules as well. So as you totally would understand, it's still analog basically, but with heart on top. In this case, it's highly integrated heart, but the nice thing is we can have loop power on the inputs, and it's got channel to channel isolation on both the input and the output module. So if you purely want an isolated analog, we've got one there. If you want it with heart as well, we've got it there as well. So we're sort of covering all the bases. Back to you, Steve.
Thank you. Okay, so not a lot to say on this one really. There's an offer for safety digital input and safety digital output modules as before, with much the same features, SIL3, etc. The main things to look at between the two sort of offers of PointIO and PointMax IO, you can see they're the same width as all of the other modules now, whereas previously you were taking panel space away by having double width modules. And a thing that I think we're starting to see with Rockwell in some of the newer products is instead of colouring every safety item bright red all over, these are signified as being safety items purely with that Guardmaster logo that you can see at the top there just next to the LEDs. Lastly, for these modules, the encoder module. So this supports both incremental high-speed counters, encoders, or SSI interface for absolute encoders up to a 1 megahertz counting frequency. As well as being an encoder module with an input function, there are also some output functions on there as well. So we can do pulse width modulation or pulse train outputs, high speed outputs there for stepper motors and the like, if that's something that you need to make use of in your wider system. With the serial module, we've got a single channel serial module covering all of the options there for RS-232, 422 or 485. Configurable and wired into that RTB in the front, and that supports the basic ASCII protocol as well as both Modbus RTU and Modbus ASCII as both a master or a slave device. So that could be very useful for communicating to some of those other third-party devices that we see out there connecting to our PLC systems and the like. Lastly here, and just very briefly, if you turn one of these modules on its side, you can see that there's some laser marking there, just detailing what each of those connections are actually there for and in what order. So nice and easy to aid in finding information when you're trying to wire these up. You've maybe not got the full documentation to hand. There's something there to help you on your way, as well as where the keying modules need to be to make those RTB compatible with those particular modules.
That's quite in depth, isn't it, Steve? But I'm sure there must be some questions and answers that will be coming in soon.
I guess so, yes.
Yeah.
Shall we move on?
Yes, let's do that.
Okay, so next is the removable terminal blocks. So as we said initially, RTB18s and RTB18Ss are the standard RTBs which you can fit for every module in this system, and they're available as either screw or push-in terminal. If you want, there are also a few specialist RTB options available as well. So for some of the selected 8-channel modules, you can see that picture on the right-hand side there of the 24-way RTB module in the front. That gives you 8 connections for connecting to your devices, and then the 2 sections at the bottom are more of a wiring solution. So they give you some onboard termination to split your plus volts and your commons into the front of the RTB itself, rather than having to do that to external terminals somewhere else in your panel. And then lastly, they put quite a bit of thought into temperature modules. Temperature modules can need cold junction compensation to calibrate those and keep them reading the correct sort of readings. And there's one of those built into these temperature modules. If you need a bit more accuracy, you can use a specialized RTB that has the CJC built into the RTB itself. Or as per usual, you can wire these out to remote cold junction compensation devices and feed that in externally, which should give you the best results if that's what you need for your particular application. So, over to you.
Let's have a look at a little demo, shall we, Steve? So this is Integrated Architecture Builder. Me and Steve use it all of the time for many things to do with PLCs, networks, etc. If you don't already use it, I suggest you download it. It is free from Rockwell. But enough of me trying to sell something that costs nothing. Let's have a little look at what Integrated Architecture Builder with PointMax can do for you. So as I said earlier on, we're utilizing this same scenario again. It's 16 digital inputs, 16 digital outputs, 4 relay, 4 thermocouple, and 8 safety in and 8 safety out. And as you can see, we've built it in IAB, and we can go a bomb with that, with all the terminals, etc. But now Rockwell have added a lovely little button that my mouse should be going to in a second, that shows we can migrate it, and it's a one-click solution to start off with. From that, you can go and have more information. There's a little button there. We can look at it. We can add a power supply if it's required, and we can choose on what format we want to migrate. Do we want to go to 16-way modules, 8-way modules, or these universal modules in the case of the digital inputs and outputs? Obviously, on the relays and thermocouples, you're limited because there's not so much choice, but I'm just drilling through just to show what there is as capabilities. And last of all, once you're happy, you can go continue, and it creates a listing and a pictorial view that can be in a Word document or a bill of materials that shows you exactly what a migration to PointMax is from Point.io. It's nice and simple, easy to do. Thank you.
Thank you, Darren. Okay. Hope that was all useful. Let's take a look at some of the key takeaways from today's webinar. PointMax IO, it's the next generation, I guess, of Point.io, which has been around for quite some time, but that doesn't mean the end of Point.io. Both of these systems are still available, they're still active, and they will still continue to coexist together for the foreseeable future. Secondly, as Darren pointed out very early on, PointMax IO is been created to work with the latest Rockwell PLC technology. So PointMax IO will not be available for use with the older 5570 control logics or the Compact Logix 5370 controllers. You will need to get up to date on the hardware to make use of this new system.
This is a nice one. PointMax works with a default 32 slot size out of the box, similar to Flex 5000. Those of you that have used Point.io will perhaps realize that you have to set exactly how many slots you're using for the slot size and adjust it as you go along. We don't need to. It's 32 slots out of the box, and you can just leave it that and plug one module in or 32. The choice is yours. As I've already said, we need to use version 36 or later of Logix Designer, but the caveats are still there that it needs to be the appropriate version should you have safety modules in there.
Okay, so PointMax IO supports ADDA, Automatic Device Diagnostic Analytics. What this means and what we're seeing is this being incorporated into a few devices now from Rockwell, including some of the drives and other devices like that, is you get some automatic basic diagnostics which can be sent up to the higher level software systems like SCADA, Factory Talk View, Optics, Asset Center, and other software systems like that. And this gives you an out-of-the-box diagnostic system for these devices in your application and your wider system. So it's an efficiency gain really from a design and engineering perspective, is that there's no real engineering and configuration to put in place to get this additional information up into the alarm and event system of your other software packages. Also, the simplification we've made with PointMax IO compared to Point.io before it is that you've now got 16 modules without having to worry about whether or not you need more module power with extra expansion power supplies, and then a further 16 modules after that, giving a 32 module system in total if need be on this application.
So let's have a look at the mounting bases. I know we've touched on this before, but just to reiterate, both the standard mounting base and the mounting base with SA power supports all the IO modules, whether they're safety or not, because as we remember, they are all the same size. And lastly, the IO modules now support Precision Time Protocol PTP and SIP sync as well. PointIO didn't do that, and that helps for time stamping data for diagnostic events.
Excellent. So where can we go for further information, Darren?
Why don't you tell them, Steve?
Okay, so if you need more literature, the product profile for PointMax is available up on the Rockwell website, as well as other technical documentation. As I said right at the very beginning, this PointMax platform is live and available today. So all of that documentation is there to support that. Darren showed on the couple of slides ago with a demonstration of integrated architecture builder that it's now incorporated into that system. You can use that to build your structure, put your bill of materials together. It will automatically include any additional devices that it needs to make that work and function correctly, like mounting bases, RTBs and so forth. It's also included in Proposal Works, another free download tool that sits alongside IAB, which is great for putting together proposals and bill of materials and selecting parts. And then, as you can see further down the list here, we've got some coming soon how-to videos, face plates into factory torque optics and the like, as well as the Device Tools app, which Darren talked about earlier on, to actually make use of that NFC function on the front of the communications module. As well as that app is also really good for registering your devices to get extended warranty. And if you've already built up all of the IO modules on the side, it should automatically interrogate that island and gather all that information for you and make that process nice and easy.
So that's the conclusion of today's webinar. I hope you've enjoyed it. I've been Darren Welsh. This has been Steve Yearle.